Hi, I am Nyalinzo. I am a recent graduate from Berea College, and the team I'm part of is called MindRoute. And the product I've built is called MindRoute 2. I first came into this project as a team, but then most of my team members got internships, so I ended up doing solo, which is one of the first obstacles I faced during this project. The project that I built is primarily targeted towards ADHD and neurodivergent people, such as me, who have a lived experience in San Francisco in the Presidio area because Google Map suggested me a route that has a lot of traffic and I almost get run over while I was in a very overstimulating environment. So I came to the conclusion of, are there navigation systems that can help a person who has ADHD or neurodivergent? And surprisingly, none of the mainstream navigation system have the least cognitive route or the most comfortable route, and instead only prioritize the fastest in arrival time or the shortest in distance. So my project MainRoute becomes an inclusive navigation prototype so that it plans a clear walking route through right now the San Francisco area with personalized cognitive load and comfort aware recommendations. So the project that I have built has two accessibilities. First, the cognitive accessibility, and second, the visual accessibility. First, the visual accessibility. I implemented two features, day and night, because I sometimes use the night feature, which is dark and which helps a lot for me personally. And when I talked to my friend who's colorblind about my project, he was like, I'm colorblind and the routes that you've created, it's not helpful. So I also implemented a colorblind friendly feature so that anybody who's colorblind can see contrasting colors. Second, which is the cognitive accessibility feature, is when I as a user input my current location, which I have set a default San Francisco location, and I put my destination, which is anywhere in San Francisco. I would generate walking routes, and this, what it does is that it goes to Mapbox and get all the routes that it generates and have those routes analyzed with features such as distance, durations, turns, crossing complexity, greenery, shade, pedestrian density, traffic, noise, construction, and point of interest density, which is shopping mall, cinema. And all of those features are passed into AI so that it can help decide which route should rank higher, which route should be recommended. So the AI that I used in this recommendation navigation system is XGBoost. What is XGBoost? XGBoost stands for Extreme Gradient Boosting, and it is a machine learning algorithm based on many decision trees, and each tree learned from mistakes made by the previous tree. So together they make a very good prediction. Now the question is, why do I choose XGBoost? I thought about the RAG system. I thought about creating my own LLM. I thought about distilling and pruning a large language model into a smaller model. But when I'm dealing with numeric data, XGBoost type machine learning algorithms are the best in those sense. And that is why I use XGBoost in my application. And as you can see here, it has generated the routes, and now it is recommending the different colors which represent the different options, the fastest, the lowest cognitive load. And in this way, any user who are using it can have an informed decision on what route they want to choose. If I'm an ADHD person, I would choose the lowest cognitive load. If I wanted the in-between, I would choose the best overall. But in general, this is the way to go. This is my project, and I want to thank Flora Yang and Dr. Jasmine Jones for this. Thank you.